Ether, esters, and anhydrides. Preparation of ether from alcohol. Ether is very inflammable and very volatile, as it very readily ignites. Vessels containing ether should not be brought near flame or allowed. Need to stay in a warm place because of the explosive nature of the substance. Place 15 centiliters of ethyl alcohol in a 500 centiliter distilling flask and add slowly with constant shaking. 15 centiliters of concentrated sulfuric acid. Close the neck of the flask with a 2-hole stopper bearing a thermometer and a drop-in funnel, as the figure 18, page 28, both of which reach to the bottom of the flask. Place the flask on a sand bath and connect it by means of a tightly fitting stopper with a long condenser, throughout which a rapid stream of cool water is passing. Use as a receiver a filter bottle which is connected with the condenser by a tightly fitting stopper. Attach the side arm of the filter bottle along a rubber tube, and which extends almost to the floor. This tube serves to conduct the vapor of the ether, which is very heavy, away from any flames present on the desk or on ambient. Heat the contents of the flask slowly. When the temperature reaches about 114 degrees and ether distilled over, add throughout the funnel 100 centiliters of alcohol, and you allow the latter to drop at about the same rate as that at which the ether distills, about 2 drops per second. During the entire time, the temperature of the mixture in the flask should be maintained at 114 degree, 145 degree. Take the receiver from the immediate vicinity of any flames and transfer the contents to a separate funnel. Shake the ether with about 1/3 its volume of a solution of sodium hydroxide. Draw off the lower aqueous layer, which should still be alkaline. Add to the ether about 1/5 its volume of a cold mixture of equal volumes of concentrated sulfuric acid and water. Shake it throughoutly. Let the mixture stand until the 2 layers become clear. Draw off the acid layer and run the ether into a distilling flask so you can distill from a water bath and collect the distillate in a receiver in the way described above. Record the boiling point and the weight of the product obtained. Ether boils at 35 degrees. Write the equation for the reaction which takes place when alcohol is treated with sulfuric acid and when the product of this reaction is heated with alcohol at about 114 degrees. What would happen if the experimental temperature were allowed to rise as high as 118 degrees? Absolute ether. For absolute ether, you shake in a separatory funnel 200 centiliters of commercial ether with 1/5 its volume of a cold mixture of equal volumes of a concentrated sulfuric acid and water. Let the mixture stand until the 2 layers are clear. Separate the acid layer and distill the ether in the way described above. Place the distillate in a dry bottle. Add 5 grams of sodium in the form of a wire on thin shaving. Insert calcium chloride. Calcium chloride tube in the neck of the bottle and allow it to stand until the evolution of hydrogen ceases. If the sodium becomes covered with a coating of sodium hydroxide, The latter can be removed by pressing upon the metal with a stout glass rod or fresh pieces of the metal may be added from time to time. For most purposes, the ether purified in this way can be used without distillation. It can be carefully decanted from the solid substances present. In order to redistill it, the ether is transferred to a clean, dry flask containing about 1 gram of sodium shaving and distilled from a water bath. Taking the precautions described above and using a carefully dried condenser and receive the first few cubic centimeters, which this should be rejected as they contain the moisture present in the condenser tube and the receiver. Note that the heater is shaken with a solution of sodium hydroxide to remove the sulfur dioxide formed as a result of the reduction of the sulfuric acid by the alcohol or by the carbon that separates. The treatment with the sulfuric acid removes the alcohol and nearly all the water. The method outlined above can be carried out more rapidly than the one commonly used, namely shaking with a solution of calcium chloride to remove alcohol and the drying, first with anhydrous calcium chloride and then with sodium. Properties of ether are volatility, for example, flammability, explosivity, and solubility. Volatility of ether. Place a few drops of ether in the palm of your hand and breathe sharply across it and explain the result. Ether inflammability. Place a few drops of ether on a watch glass and apply a lighted match. Explosive mixture of ether and air. Hold for about 50 seconds the neck of an open bottle containing ether over an empty wide mouthed through 15 centiliters bottle and then drop a lighted match into the latter. Solubility of ether in water. Test roughly the solubility of ether in water as follows. Into a 100 centiliters flask, place 5 centiliters of ether and add 14 centiliters of water. Close the flask with a stopper and shake vigorously. Add water in portion of 5 centiliters and shake each time until the ether is completely dissolved. State the solubility you find as the result of your experiment. Solubility of water in ether. Shake 10 centiliters of ether with 10 centiliters of water. Decant off the ether throughout a dry filter paper into a dry test tube. Test the filter and the ether for water by means of anhydrous copper sulfate. Is water soluble in ether? Solubilities of ether. Test the solubility of ether in equal volume of alkyl benzene, petroleum ether, dilute hydrochloric acid, concentrated hydrochloric acid, and a solution of sodium hydroxide. Solubility of ether in sulfuric acid. Add very cautiously to 2 centiliters of ether, about 5 centiliters of concentrated sulfuric acid. The tube should be shaken underwater to keep the mixture cold. Is ether soluble in concentrated sulfuric acid? Pour the mixture slowly into a test tube containing cracked ice. Are 2 layers formed? Explain what you see. Reaction between ether and sulfuric acid. Repeat the experiment, but warm the mixture gently over a free flame before it is poured onto the ice. Are 2 layers formed? Yes, explain what you see. Ether and sodium. Add a shaving of sodium to about 5 centiliters of absolute ether. If a gas is moved, wait until the evolution ceases and add a fresh piece of sodium. Explain the result. If anhydrous ether is not available, the experiment can be performed with ordinary ether, but a number of additions of sodium will be necessary before the metal does not react with the liquid. Why? The composition of ether by hydrochloric acid. Mix in a test tube kept cold by immersion on water 1 centiliters of ether and 3 centiliters of hydrochloric acid. Lead the tube by means of a cork to a delivery tube bent at a right angle. The end of the tube should extend nearly to the bottom of the test tube, which is placed in cold water. Heat the mixture of acid and ether carefully. When about 1/3 of the liquid has distilled over, add a little water to the contents of the cold tube and shake. Are there 2 liquids? is 1 heavier than water. Preparation of a mixed ether, isoamyl ethyl ether. Place 15 grams of isoamyl alcohol in a 200 centiliters round bottom flask provided with a reflux condenser. Add slowly throughout the condenser 6 grams of sodium cut in small pieces. The alcohol may be heated slightly to hasten the reaction. When all the sodium has dissolved, add cautiously throughout the condenser as the reaction is apt to be a violent one. 13 grams of ethyl bromide, heat to boil for 1 hour. Distill directly from the flask using water condenser and collect the distillate in the following fraction: 18 degree, 110 degree, 110 degree, 114 degree, 114 degree, 120, 120 degree, 113. Fractionate twice. Register the portion boiling at 110, 114 and collect and weigh the part which distilled at 111, 130. Determine the specific gravity of your product and determine whether it dissolves in concentrated sulfuric acid. Calculate the percentage yield of ether obtained from the ethyl bromide used. The yield in the experiment should be about 15%. Isoamyl ethyl ether boils at 120 and has the specific gravity of 0.764 at 18 degrees. Note that an excess of alcohol is used in the experiment to facilitate the reaction between it and sodium. Sodium isoamylate is a solid which is soluble in isoamyl alcohol. The sodium and ethyl bromide are used in the proportion of 1 atomic weight of the former to 1 molecular weight of the latter. Preparation of properties of acetic anhydride. Place 50 grams of freshly fused sodium acetate in a 215 centiliter distilling flask. Connect the flask with a condenser. And for the preparation of fused sodium acetate, see experiment below. And connect the flask with a condenser and a receiver using for a latter a distilling flask, which is fitted tightly to the condenser by means of a stopper. Protect the inside of the flask from moisture by connecting a dry tube to the side arm of the receiver. Insert in the neck of the flask a cork bearing a separator funnel which contains 14 grams of acetyl chloride. Immerse the flask in cold water and add about 1/2 of the acetyl chloride very slowly. The liquid should not be allowed to get hot enough to boil. Disconnect the flask from the condenser and shake it cautiously while it is still in the water. Replace the condenser and add the rest of the chloride. If any liquid distills over during the addition of the acetyl chloride, it should be returned to the distilling flask. Replace the preparatory funnel by a cork and distill, keeping the flame in motion to avoid local overheating. Add about 2 grams of fused sodium acetate to the receiver and distill. Note the boiling point of the liquid and weight the product obtained. Calculate the theoretical yield and the percentage of these obtained in the experiment. If the substances from which the anhydride is prepared are not brought together in the proportion represented by the chemical equation from which substances should be theoretically yield be calculated. In the above experiment, which substance is used in excess? Why? Acetic anhydride boils at 138 degrees. The yield should be from 13.5 to 13 grams circa. Acetic anhydride and water. Add about 1 centiliter of acetic anhydride to 5 centiliters of water. Do the two liquid mix, shake the test tube vigorously and funnel warm gently. Acetic anhydride and sodium hydroxide. As far as is concerned, acetic anhydride and sodium hydroxide, you shake 2 centiliters of the anhydride with 5 centiliters of a solution of sodium hydroxide and write the equation. For acetic anhydride and alcohol, repeat the experiment. For identification of acetic anhydride, add casually 2 centiliters of acetic anhydride to 2 centiliters of aniline and heat the mixture to boiling. Pour the product while still hot into 20 centiliters of cold water. Shake vigorously, decant off the water and wash twice with cold water. Dissolve the product in boiling water, avoiding an excess of the solvent. Filter hot throughout a fluted filter paper and cool the solution in running water. Filter off the crystal by suction. Dry them on a porous plate and determine their melting point. If the compound does not melt sharply, it should be crystallized from boiling water. Acetanilide, the product of this reaction melts at 160 degree, boils at 304 degree, and crystallizes from hot water in colorless prisms. Note that the first distillate is redistilled from a small amount of sodium acetate in order to convert any unchanged acetic chloride into anhydride. And the reaction B, C, and D apply in general to anhydrides and are useful in their identification. Determination of the physical properties of the acids or esters formed is often made in the identification of anhydrides. Sulfuric acid is a valuable catalytic agent in the reaction which takes place between alcohols and anhydrides. The chemical reaction in this test is analogous to that which takes place between anhydride and ammonia, and is CH3 CO2 times O plus 2 ammonia gives CH3CO and H2 plus CH3COO and H4. Aniline is related to ammonia. Its formula is NH2C6H5. The reaction with acetic anhydride takes place according to the following equation: CH3CO 2 times O plus 2 and H2 C6H5 gives CH3CO and C6H5 plus CH3COO and H3C6H5. In the case of ammonia, acetamide is formed. The product with aniline is acetylanilide. The second substance formed is the aniline salate of acetic acid. It is soluble in water and is readily removed when the product of the reaction is crystallized. The preparation of anhydrides in this way from acid anhydrides is often effected in the identification of anhydrides. The anhydrides are solids which can be readily purified. As a consequence, an identification can be accomplished with a very small amount of substance. Preparation of a succinic anhydride. Heat to boiling for about 1/2 hour in a dry round-bottomed flask. Provide with a return condenser a mixture of 10 grams of phosphorus oxychloride and 15 grams of succinic acid. It is advisable to use a return condenser like the one illustrated below. When the flask is cold, add 15 centiliters of acetone and heat on the steam bath until the solid has dissolved. Filter hot and set aside to crystallize. Filter off the crystals by suction and wash them with a few cubic centimeters of cold acetone. Weigh the product and determine its melting point. Calculate the percentage yield. Succinic anhydride melts at 120 degrees. It may be crystallized from hot chloroform, in which it is difficulty soluble, or from acetone. Phosphorus Oxychloride is used as a dehydrating agent in this preparation. The reaction takes place according to the following equation. 2 molecules of CH2COOH2 plus POCl3 gives 2 molecules of CH2CO2O plus HPO3 plus 3HCl. Esters. Preparation of potassium ethyl sulfate. Pour into a small flask 20 centiliters of ethyl alcohol and add slowly with constant shaking 10 centiliters of concentrated sulfuric acid. Connect the flask with a flux condenser and heat on a boiling water bath for 1 hour. Cool the liquid and pour it slowly into 260 liters of cold water. The solution contains ethyl sulfuric acid, alcohol, and sulfuric acid. The acids are separated by making use of the fact that barium ethyl sulfate is soluble in water and barium sulfate is insoluble. Add to the solution with constant stirring smaller quantities of barium carbonate as long as carbon dioxide is boiled. Filter in a porcelain funnel and wash the precipitate twice with about 20 centiliters of hot water. The filtered solution contains barium ethyl sulfate. Write equations for all the reactions. Test 5 centiliters of the solution for barium in the usual way. Test the solution for a sulfate. Results: heat about 5 centiliters of the solution with about 1 centiliter of dilute hydrochloric acid. And write the equation. Conversion of barium ethyl sulfate into potassium ethyl sulfate. Heat the rest of the solution of barium ethyl sulfate to boiling and add the solution of potassium carbonate until the solution is slightly alkaline. Equation: fills hot. Wash the precipitate twice with a small amount of hot water and evaporate the filtrate to crystallization on the steam bath. When cold, filter off the crystals and wash them with a little cold alcohol dry on a porous tile. This can be recrystallized from boiling alcohol. Preparation of ethyl acetate from alcohol and acetic acid. Mix in a dry 200 centiliters distilling flask 15 grams of alcohol, 60 grams of glacial acetic acid, and 4 centiliters of concentrated sulfuric acid. Cover the side arm of the flask with a cork bored halfway throughout its length. Connect the flask with a reflux condenser and heat to boiling for 30 minutes. At the end of this time, arrange the apparatus for distillation using water condenser and having a thermometer to record the temperature of the vapor. Distill into a flask when temperature registers 100 degrees. Collect separately about 1 centiliter of the distillate and add it to about 5 centiliters of water. If the mixture does not separate into 2 layers, stop the distillation. Shake the distillate in the flask with 13 centiliters of water and add sodium carbonate until a drop of the ester is neutral to moisten the litmus paper. Transfer to a separatory funnel, draw off the water and shake the ester twice with a saturated solution of calcium chloride using 15 centiliters each time. Draw off the ester into the distilling flask and add about 1/4 its volume of anhydrous calcium chloride. Close the flask and cover the side arm with corks and let stand for at least 1 hour. Distill from a water bath. Note the boiling point and the weight of ester obtained and calculate the percentage yield from the acetic acid used, while from the acetic acid, ethyl acetate boils at 70 degrees has the specific gravity of 0.9028 18 degree 14 degree 4 degree as a range, and is soluble in 70 parts of water at 70.5 degrees. The yield should be 18 to 85% of the theoretical. Note that the sulfuric acid used in the preparation serves as a catalytic agent. The amount of alcohol used in that equivalent to the acid equal molecular portions, plus that which combines with the sulfuric acid to form ethyl hydrogen sulfate. We are speaking about moles. The ester obtained in the first distillation contains alcohol and acetic acid. The former is removed by shaking with calcium chloride and the latter by treatment with sodium carbonate. Formation of ethyl acetate from acetyl chloride and from acetic anhydride. Consult your notes on experiment 79 G and H at page 15.8. If you have not carried out experiments, do so now. Properties of ethyl acetate are hydrolysis. For example, hydrolysis of ethyl acetate. Place 25 centiliters of ethyl acetate and a solution of 40 grams of sodium hydroxide in 200 centiliters of water in a round bottom flask connected by a tightly fitting cork to a flux condenser. Place the flask in boiling water and heat until liquid ceases to flow back from the condenser about 3/4 of an hour. Transfer the liquid to a distilling flask and distill of 15 centiliters into a small flask. Reserve for future storage the contents of the distilling flask. Add sodium potassium carbonate to the distillate in small portions. Close the flask and shake it. Repeat the addition of the salt until a part of it remains undissolved. Pour the 2 layers into separate final run of the lower equation solution. Shake again with a small quantity of dry potassium carbonate. Place the alcohol in a small distilling flask at about 1/4 its volume of anhydrous copper sulfate and allow the mixture to stand about 15 minutes with occasional shaking. Distill the alcohol and water back directly from the flask and note its boiling point. Apply the iodoform tests to a few drops of the alcohol. Make the original aqueous solution obtained the hydrolyzed strongly acid with dilute sulfuric acid equation bright and distill over 15 centiliters. What does the distillate contain? Prove your conclusion by a suitable test. Explain how the procedure used in this experiment serves to separate an acid and an alcohol. Is the process one of general applicability? Explain how. Ethyl acetate and concentrated sulfuric acid add gradually with constant shaking and keeping the mixture cool by running water 2 centiliters of ethyl acetate to 4 centiliters of concentrated sulfuric acid. Put the solution very slowly, keeping the tube cold into 10 centiliters of cold water. With this test, distinguish an ester from an ether from a saturated hydrocarbon. Repeat the experiment, but heat the mixture for minutes at about 100 degrees before adding the solution to water. And write the equation. Ethyl acetate and hydrochloric acid. Repeat experiment using ethyl 96.J using ethyl acetate in place of ether. And for what is the test used? We likely give a positive result. Preparation of isomer acetate from sodium acetate. Place in a 750 centiliters round bottomed flask provided with a return condenser, 16 grams of finely powdered under sodium acetate, and add throughout the condenser very slowly 70 grams of concentrated sulfuric acid and next 65 grams of isomer alcohol. It on a wire goes for 1/2 hour. Connect the flask with a condenser arranged for distillation and distill as long as liquid passes over. Pour the distillate into separate funnel and wash it twice with an equal volume of water. Separate the ester and dry it over anhydrous calcium chloride. Pour off the liquid and distill, collect and weigh the portion with boils at 137 degrees 104 degree. Calculate the theoretical heat from the sodium acetate used and the percentage of these obtained. Test the solubility of isomer acetate in concentrated sulfuric acid. Isomer acetate boils at 139 degrees. The yield should be about 67 grams. Note that it is often advisable to prepare esters from salts rather than from the free acids. The salts can be more readily obtained in a hazardous condition. Acid being sold, smaller quantities can be handled conveniently. In the preparation of esters from salts, enough sulfuric acid must be added to liberate the organic acid. Equal molecular quantities must be used, since acid sulfides are formed. A small excess of sulfuric gas should be present to act as a catalytic agent. Enough of the alcohol is used to interact with both the organic acid and the excess of sulfuric acid.